Welcome to the Global Issues Daily. Today, we're jumping right into one of the most dangerous, powerful, and frankly isolated environments on Earth. We're diving into the high-stakes extraction of the black gold that essentially drives our entire global economy. Think about it. The petrol in your car, the gas heating your home, even the plastic in the device you're probably using right now. Almost everything modern society relies on begins its life in a place most of us will never actually see. So, in this Explicker, we're going to unpack exactly how that happens. Now, you might be wondering, how does oil actually make that incredible journey from the deep, unforgiving ocean floor right into your daily life? Well, I can tell you, it's definitely not just about digging a hole in the ground. It is an incredibly complex, inherently dangerous masterpiece of modern engineering. Let's break down this journey step by step, from miles beneath the seabed straight to the tanks of a giant transport ship. Let's start with Section 1. The offshore megastructures. The financial gravity of this whole operation is just immense. Constructing just one of these offshore platforms, you're looking at a cost of anywhere from $5 to $10 billion. And physically, they are absolute behemoths. We're talking structures that tower 300 to 600 feet high. To put that into perspective, that's taller than the famous Qutb Minar. Some of these rigs are fixed directly into the solid seabed, while others actually act as heavily anchored floating vessels. And that multi-billion-dollar price tag? It's absolutely necessary because these structures are built out in the unpredictable open ocean. They're engineered for supreme resilience. I mean, they have to withstand towering 30-meter waves, which is literally a 10-story wall of water, and survive direct hits from Category 5 storms without even budging. Because of this extreme isolation out at sea, the platform essentially has to function as a self-sustaining floating city. They house anywhere from 200 to 500 workers who keep the rig running 24 hours a day, 7 days a week. And since crews are stationed there for months at a time, the megastructure is outfitted with its own hospital, a helicopter pad, fully equipped gyms, and massive dining halls. It is quite literally an isolated metropolis dedicated entirely to energy extraction. Moving on to Section 2, drilling the deep seabed. This is where a highly specialized piece of machinery called a rotary drill comes into play. Powered by that towering derrick you always see on top of the rigs, to actually reach the oil, engineers have to drill down 1,000 to 5,000 meters. First, they cross the ocean water, then hit the seabed rocks, and then bore straight through distinct geological layers. To cut through all that stone, the drill bit is made of incredibly tough materials like diamond or tungsten carbide. And throughout this grueling 60 to 100-day process per well, an engineered chemical mixture called drilling mud is continuously pumped down. This vital fluid cools the rock, lubricates the drill bit, and most importantly, keeps the immense underground pressure under control. And managing that pressure is absolutely crucial. When the drill finally breaches the oil reservoir, the underground pressure pushing back up is intensely violent. If the oil and gas spiral out of control, you get a blowout. To prevent this, platforms are equipped with what's called a BOP, or blowout preventer. It's essentially a massive emergency valve system capable of shutting down the entire well instantly. When a BOP fails, the results are catastrophic. In fact, it was the failure of a BOP that caused the tragic Deepwater Horizon oil spill back in 2010. Which brings us to Section 3, extraction and separation. Now, you might think extracting the oil always requires massive, heavy-duty pumps right from the start, but that isn't always the case. Often, the natural underground pressure is so immense that opening the well is like opening a violently shaken bottle of soda. The oil simply rushes up to the surface all on its own. We call this natural flow. However, when that pressure inevitably drops over time, engineers have to switch to artificial injection. They'll lower submersible pumps or inject gas back down into the reservoir to artificially increase the pressure and force the rest of that crude oil upward. But the liquid that erupts onto the platform isn't just pure oil. It's a chaotic, highly pressurized mixture of oil, water, natural gas, sand, and chemicals. This brings us to a vital piece of tech, the three-phase separator. It's basically a horizontal drum that uses gravity and pressure to organize all that chaos. The heavier water sinks straight to the bottom, the valuable crude oil settles in the middle, and the natural gas rises to the top. Actually, that gas is either piped away or burned off safely, which is that iconic gas-flaring flame you often see on offshore rigs. The water is treated and returned to the ocean, leaving us with the crude oil, which is then filtered and strictly temperature controlled. And the scale of this daily operation? It's breathtaking. A single, medium-sized platform can produce anywhere from 50,000 to 200,000 barrels of crude oil in just one day. So where does it all go? Let's look at Section 4, massive floating warehouses. With hundreds of thousands of barrels being pulled up every single day, it has to be stored immediately. This happens in a megastructure known as an FPSO, which stands for Floating Production, Storage and Offloading Vessel. Think of this as a colossal floating factory and warehouse that remains permanently anchored right next to the oil platform itself. These vessels are true titans of the sea. They measure 250 to 330 meters long. That's roughly the length of 3 American football fields laid end to end. Inside, they can store a staggering 1 million to 2.5 million barrels of crude oil. And those massive tanks are meticulously temperature controlled. Why? Because if crude oil gets too cold, it actually thickens up, making it nearly impossible to pump out later. On board, sensors are constantly monitoring temperature, pressure, and volume 24 hours a day, relying on what's called custody transfer metering. When you're dealing with millions of barrels, extreme precision is absolutely non-negotiable. If a sensor miscalculates the volume by even a tiny fraction, it equates to a loss of millions of dollars. So the data flowing into the control room is scrutinized with absolute razor-sharp precision. Next up, Section 5, docking the giant tankers. Once the oil is finally ready for the global market, a VLCC, a very large crude carrier, approaches. Measuring 330 meters long and 60 meters wide, we are talking about a ship the size of a small neighborhood, navigating the open ocean. Bringing a vessel this massive right up next to a platform filled with millions of barrels of highly flammable oil is exceptionally risky. A single error in calculating wind, speed, or ocean currents could result in a catastrophic explosion. Because of this, specialized marine pilots, experts who dedicate their entire lives to this specific high-stakes maneuver, are brought in to coordinate the docking. The mooring process is a strict, zero-mistake operation that takes anywhere between 4 to 6 hours. Constant radio communication locks down the exact positioning. To prevent the ship from drifting even an inch, it's tied down to the FPSO using thick steel ropes that weigh a massive 100 kilograms per meter. Finally, a giant flexible cargo hose is securely connected between the 2 megastructures. The ocean really doesn't give second chances, so every second of this timeline has to be executed flawlessly. And finally, Section 6, fueling the world. Once everything is locked in, a signal is given from the control room, and the mechanical power unleashed is just awe-inspiring. Massive 5,000 horsepower pumps roar to life. They begin pushing 50,000 barrels, that is 8 million liters of crude oil, from the FPSO directly into the tanker every single hour. This monumental transfer takes anywhere from 24 to 48 hours to complete, and during this entire time, the environment is on maximum alert. The dedicated oil transfer team enforces a strict, unbending rule: 0 sparks, 0 flames anywhere near the operation. Every single liter is accounted for. Once the tanks are totally full, documents finalizing a transaction worth billions of dollars are signed off. The mooring lines are released, and that giant tanker slowly turns toward the horizon, heavily laden with a fuel that will soon hit global refineries to become our diesel, our plastics, and even our medicine. It's a truly monumental cycle of engineering, economics, and sheer human endurance. So I'll leave you with this thought to take away. Next time you stop at a petrol pump, or even just pick up a plastic device, pause for a second. Think of the thousands of workers risking their lives out at sea, managing explosive pressures and raging storms just to keep our world moving. Thank you for joining this explainer on the Global Issues Daily. If you found this breakdown valuable, please leave a like and subscribe to the channel for more in-depth analysis of how our complex world is built. I'll see you in the next one.